I want to thank Alfredo Martinez and the other organizers of this meeting for the invitation to come, and actually to invite a non-genomics interloper, perhaps, to kind of set the stage for, and to, in a way, challenge the group to figure out ways to decrease the use of dietary reference standards or reference intakes as you develop new ways of coming up with and developing personalized nutrient recommendations that should lead to improving the health of individuals and hopefully of populations. Well, let's see, let's try that one. Okay, so my goals today are to explore what the current uses are of nutrient reference values and to show how, give you some thought for how can you use information on personalized nutrition to better inform nutrient reference values, which at this point at least are probably more where you have an N of 1, or for a population where in the United States we may have 300 million, in some of the smaller countries in Europe it may be 3 million. And then to talk about, well, what's needed before personalized nutrition would supplant nutrient reference values. Will it take the next 10 years, or are we looking at another 100 years to be able to get to establishing ways of working with population needs? Well, there's been a changing landscape, I think, over the last 50 years, because nutrition science has moved from a concern about inadequacy to a concern about excess for many nutrients or components in foods. We heard the previous speaker talking about using food quality scores, and when you look at what the quality indicators are, diet quality scores, they're primarily focusing on things that in many cases we need to limit, and not so much, and things to increase, not so much to prevent a deficiency sign or symptom, but to move an individual to decreasing risk of chronic disease or improving health in the long term. And then we've moved from a dependence on methods that is for assessing adequacy or excess based on a whole organism response, where we're looking really at disease outcome, to dietary changes, to unveiling new cellular or epigenetic modification information that we may have to relate diet, and in so doing, search for a biomarker that can be used in a consistent manner. So the issues, at least, as you've got certainly in the program for this meeting, and certainly for most policymakers in various roles within governments, the issues that we're dealing with deal with trying to stem the tide of the increase in obesity, figure out how to, at the same time, improve nutrition of nutrients that may not be where you don't see deficiencies, but where there may be important needs to increase intakes, and then certainly to try and determine roles related to chronic disease. But as you're well aware, our populations are not homogeneous. We have such a heterogeneity, and partly that may be responsible for why the research findings that we do have when we do studies turn out to not provide clear-cut answers, or maybe they haven't even been asked the right questions. And we're also, at least certainly in the United States, we have consumers that have expectations for what food can do for you when we don't have all the information in, but we have to make decisions in terms of policy. Nutrition research typically has focused then on validating biomarkers of chronic disease, trying to identify them, but in so doing, figuring out what are the mechanisms of action, and then how do they interact with other nutrients, bioactive components, looking at what's the difference in populations, and that's certainly what we've heard today and the focus of a lot of this conference. And then looking at the influence of environment versus hereditary, if you're looking at body weight or looking at other aspects of chronic disease. And then an important part is to look at the time course between initiating preventive measures and seeing effects on actual outcome. And that's one of the reasons, of course, to look for biomarkers that may indicate the potential increased risk of an adverse situation. So what do we do, though, in the meantime? Well, there are 3 areas I'd like to talk about. Certainly one is dietary guidance, food fortification or supplementation for specific nutrients or for specific foods, and then routes to providing nutrition information. Well, if you go back, way back, you can find dietary guidance from Hippocrates in 370 BC, which was persons who are naturally very fat are apt to die earlier than those who are slender. Well, we had heard Dr. Bouchard saying a few things along that line. So we have, we've got 2 millennia of looking at what's the impact of diet on health. Before the 1800s, Benjamin Franklin in the United States had a number of sayings which all show that, yes, there was a recognition that there was a role in health, maintaining health, of certainly body weight. Now, we have been able to chronicle longevity for individuals, and here are 3 examples of individuals from around the world, from Italy, from France, and Japan. And when they were asked what was their key to, what did you eat, you see, to some extent, the Mediterranean diet. From Italy, from Japan, high fish, high rice, vegetables, and again, an olive oil. Now, I'm not sure how chocolate got in there, but that sounds good to me, so. And I have to throw in my own grandmother, who lived to 103. I doubt that I'll make it. But these were her guidelines, and this was before really the dietary guidelines came out. But I remember having wheat cereal, using molasses and honey, and certainly a lot of physical activity. She used to ride a bicycle until she was 93. Now, we have other types of dietary guidance in the United States, and many countries do. And this has changed over the years, but if you look at the food groups, they're about the same, although there's kind of a difference in order that's certainly been exemplified by the food guide pyramid when it came out with having fats, oils, and sugars sparingly. And that's very similar today. Dietary guidelines in the United States have been around since 1940 in very specific ways, and over the years they have changed from the number to the point that in 2005 there were a number of recommendations. There were essentially 8 major recommendations and then a total of 23 specific ones in subcategories. Now, the new ones for 2010 are going to come out. Hopefully they'll make it before it becomes 2011, but I can't guarantee it. That's not something I'm responsible for, thank heaven. But these are ways to let the public have an idea of how to eat, where it's important to get messages across and base public policy on. Now, what contributes to developing dietary guidelines in the United States? We have a number of things that go into it. We have nutrient databases, as mentioned by Dr. Feskin. We have other types of guidance. We have research studies that are done in human nutrition centers and in universities. And then we have we within USDA maintain the food intake survey component of NHANES, which is the What We Eat in America survey, to give an idea of what people are eating, and then through that be able to look for associations with specific disease indicators or outcomes. Now, what else is the basis of those? Well, it goes back a number of years. This is actually the first set of RDAs that came out from the National Research Council in 1941. It's about 30 pages. That's actually a copy of it. And it covered about 9 nutrients and energy. Well, that grew over years, and I had the pleasure of being responsible for it growing to this size, over 2,500 pages, and involving over 100 scientists in the United States and Canada to develop dietary reference intakes, because there was a need for a number of things. More information about where the numbers are derived to better use the numbers so that they're not applied inappropriately, and to provide not only a recommended intake, but a value that could be used to assess population intakes, and a value to assist policymakers in determining when might a nutrient, because of the changing food supply and the changing availability of individual nutrients through new technologies, when would it be perhaps inappropriate to have higher intakes of a nutrient. So with that in mind, the upper level was established. So the dietary reference intakes are a significant expansion in providing reference values for use, but they're not always used in the correct way, and there's only uses that one has to pay attention to. And certainly when you talk about an N of 1 for a single individual, you do want to know as much as you can about that individual. So the DRIs are developed by age, by gender in some situations, but beyond that, there's not enough information to develop quantitative estimates other than in the group there is a difference related to folate because of a concern about neural tube defects and B12 malabsorption due to age. So those two are maybe more specific, but again, they don't get into the extent of the changes in gene pools that you'd want to have if you were trying to establish something based on significant personalized information. Well, what are they based on? Well, they're based on data such as this, which shows for various communities. This is the iodine prevalence related to goiter, and as the urinary iodine intake increased in groups of children in various areas, these are all different countries, these are average, you see a decrease in the percentage of goiter. So this is the type of information then that was available to try to establish the average requirement of about 100 micrograms and then an RDA of 125 micrograms. In terms of vitamin C, as another example, the data was available essentially from a group of, excuse me, I'm recovering from a cold. Speaking of vitamin C, perhaps I should have had a little, I don't know. Group of subjects in a defined study at which, giving them increased levels of vitamin C, there was an increase in ascorbate concentration and an inhibition of superoxide production by neutrophils. So this then was used as the estimate of adequate for what? That's an important question when you review the dietary reference intake documentation, is to see what was used as the parameter to establish the amount needed for an adequate diet. And then what does that do for you? Well, if you have a level at which half of the individuals showed that level of adequacy, that essentially corresponds to an estimated average requirement, which in English is an EAR. And so for women, for vitamin C, it's 60 milligrams, for men, 75 milligrams. And when those values then are applied against a data set, in this case it's the N. Haynes data from 2003 through 2004, there's a percentage of individuals, the percentage below the cut point, that would be considered to have a diet inadequate, meaning that the percentage should be about 10%, would not have the level of saturation for ascorbate in neutrophils, or for men it was 21%. Now, what does this mean? It does not mean that this group has scurvy, this 20%. It means that, in fact, they don't have this level that was assumed to be the important component of adequacy, having adequate ability to deal with superoxides within the white blood cells. So using that methodology, if you apply it to the N. Haynes, What We Eat in America, the survey that we do at USDA for 2001 and 2002, and group all of the age groups together, this essentially shows you the percentage of the population going from, in the case of vitamin E at 93% to vitamin C at 31% or folate at 8%, whose diets would be considered inadequate. Well, now again, we don't have a level of vitamin E deficiency where we're concerned about red cell hemolysis, but it indicates that either we have to have a better indicator of adequacy, therefore more studies, and since this came out in, I believe in 2000, the average requirements for vitamin E, there's been a lot of new research done. And for something like folate, is there 8%? Could be. That might be more appropriate in the US population. So this is essentially the use of the average requirement. Now, one of the reasons to develop a group of different kinds of reference intakes is so that they can be used in various ways. You just saw the average requirement being used to assess a population group's intake. But there are many uses for reference values, and the question I was posed was, well, are they still needed in the era of personalized nutrition? Well, as a guide for procuring food supplies for groups of healthy people, if it's a heterogeneous population, yes, you have to have some way of deciding how much do you provide, what would be considered a diet that would meet all the individuals in that population group's nutrient needs. So this would be typically what you do in a school setting or in military feeding. Military feeding, you're going to provide more of many nutrients because it's more active individuals than you would in a school setting where they're younger and they have lower calorie requirements. So you have to have some basis when you're planning foods. And of course, you might want to add foods just to improve palatability and taste. But in terms of coming up with procuring food supplies, it's an important component. And as I showed you, it's a reference point for evaluating dietary intake in subgroups. And so this is usually done through assessing intakes and from there looking for nutrients that may be at risk in that group. Again, when you don't know anything about or much about the population or about the subgroup. And as a basis for nutrition education programs that are going out to a large population group where there's not as much known. One of the examples in the United States is for our current food labeling, where we have nutrition facts and then supplement facts, and they're based on reference daily intakes coming out of RDAs from 1968 on, or daily reference values which are more related to chronic disease and have come from other sources. Well, so you need reference points for labeling or for nutrition information, again, to a population group, not to an individual. And that's actually one of the problems with using DRIs for the individual is that you really don't know what the extent to which the nutrient reference value is going to meet that individual's need. You assume it will because it's been developed by looking at a small group of individuals or populations, but whether there are new characteristics in that individual, that's probably where personalized nutrition will have its greatest impact. We also, in many countries, and certainly in the US, fortify our food supply where we have nutrients that we know are important, such as iodine or vitamin D, and we need to have sources since data shows that there's not enough in intake. So there may be other subpopulations in a group where even more is needed, but where there may be concerns about upper levels for the rest of the population. In that case, individual supplements may be more important. So what are the appropriate uses of NRVs? From my perspective, at this point in time at least, certainly for assessing intakes of groups, for planning, for examining the adequacy of the food supply for what is assumed need of a population. It can be used for recommending intakes for individuals when you know very little about that person, you don't have their genetic profiles, and when you're looking at nutrition education. And you have to have something to base public policy on. But are they going to be relevant? Are they relevant now? I think so. Will they be relevant 10 years from now? That's a question, I think, that as you all do what you do, we'll get more and more to making many of these values perhaps be irrelevant. And maybe a century from now, they will be actually irrelevant. But, you know, I hope that the 2099, there is not an RDA that anyone's talking about, that we've gone way beyond that 100 years from now. But in 2020, where will we be? We've heard earlier about life stage, looking at perinatal development, looking at early nutrition programming and subsequent effects on phenotypes. I think we're learning more about that. That's an important new issue. That's my grandmother at 7 months, at 96, and that's my granddaughter. So that's the 5th generation. What is the impact of what my granddaughter will have in terms of risk based on what I've done or what my grandmother did? What are the interactions? We've heard a lot about inflammatory response. It's a key to so many of the things going on. And as we delve into that, certainly the effect on upregulation is going to be important to evaluate. And other things that we're doing at USDA, at my center, is looking at using a pig model to look at immune response as a model for human disease, to look at the impact of obesity on some of these components, looking at microbiological defense mechanisms. All of these are things that we'll get into what our future interests are, looking at gene and genomics and nutrigenetics. And I have to say, I found an interesting article by Leroy Hood looking at what systems biology has in store for us. From his perspective, he thinks that there is a convergence of systems approaches to disease. We have new technologies, new measurement methodologies. You've heard about some today. I'm sure we'll hear more the rest of the week. New computational mathematical tools are required, and they're what's got to be there as we push to these new frontiers, so that we're going to change medicine from being reactive or responsive to disease symptoms to being predictive. And that's really what we're trying to talk about here, I think, and estimating the likelihood of determining future health by determining individual genome sequences. He envisions a handheld device that you prick the finger and quantify 2,500 organ-specific proteins from all your organs, that there'll be wireless transmission of this to a server where analytical results will send a report to you and to your physician, and you'll have instantaneous assessment of your current health status. But each of us differs by 6 million nucleotides. So the recommendations are going to have to be individualized because these assessments will end up being individualized. So in 2020, what should NRVs be based on? Recommendations for the individual will be individualized where you have individual data, but for groups, they'll be used to determine when fortification or supplementation is needed, to decide on the best way to increase an individual's intake, and when you're assessing how you can change intakes. And so therefore, from my perspective at least, NRVs will be individualized to the extent possible when we know something about the heterogeneity of the population. Thank you.